All right. So here you guys go. Keystone prep and number science. So the whole point of this is to just get you guys thinking more logically. Okay. It's not about doing all of the math in this section. It's about kind of figuring out how much math do I actually have to do in order to solve the problem. Okay. Now, Marcus, why am I telling you that? Why am I not just telling you to do the whole problem? That is one part, but the other thing is time, right? Keystones are time, but the SATs are. And time is a big factor on kids, and it weighs on them. And you start freaking out in the middle of the test, you're like, oh my gosh, I'm running out of time, I'm running out of time. So what I like to do is I like to try and teach you ways to save you a minute or two so that maybe later on a problem that you want to get right, but you just need more time, you have that time. Make sense? Now, the way I teach square roots is a little bit different than most teachers. Most teachers say, you need to remember or memorize all of the perfect squares. I don't like that. I like to memorize it this. It's just a factor tree, and I'm just looking for pairs. What do I mean by a factor tree? Well, first off, let me write the problem up here. It's asking for what values of x can I further simplify this? Now, with square roots, we're looking for pairs of numbers. When you have a pair of numbers, you circle and pull it out. Well, what do I mean by that? Well, if I'm talking about the square root of 9, we all know it's 3. But 9 can be broken down to 3 and 3. And notice, there's my pair of numbers. So when I have my house, this pair of numbers comes outside, and whatever doesn't have a pair gets left inside. So using this concept, Marcus, let's break down 33. Give me 2 numbers that go into 33. I don't care what they are. They just have to go in.
1 and 3.
All right, I lied to you. Can't use 1. Never use 1. It's got to be a different one. So 3 goes into 33, like you said. But what's the other one? 3 times what gives me 33?
2 times 11.
Can I break down 3?
No.
Can I break down 11 anymore? No. So x needs to have either a 3 in it or an 11 in it, meaning one of these 2 numbers needs to divide into x. Does that make sense to you?
Yeah.
So Marcus, let's look at these numbers, 7, 13, 15, 35. 7, the factors of 7 are 1 and 7, right?
Yeah.
That's not 3 and 11, is it? So my answer is not 7. 13, maybe factors of 13 are 1 and 13. Ooh, not it, right? 15. 2 numbers that go into 15. 3 and 5. Oh, wait. There's my pair of 3s. That 3 and that 3. They would pair up and get pulled out. So my answer would be 15 because I could further simplify it. Now, I am a big algebra guy. Not sure if you guys realize that. I like to use algebra a lot. Big fan of it. Don't know why. It speaks to me. It's like concrete. Simple. So when I'm doing a problem like this, I'm being asked to make 3 root 17x equal 18 root 17. Right, Rachel? That's all I want to do. But here's my thing. I like algebra. Algebra makes this problem simple. If you don't like it, I'll teach you a way in a second to do that problem without algebra. But here's how you do it with algebra. All right? Using properties of square roots, we can break up root 17x to root 17 times root x. Right? There's nothing wrong with that. Rachel, I'm allowed to do that, right? That equals 18 root 17, correct? Now, I'm viewing this root x as like my variable, so I want to get rid of this 3 root 17. So I divide by it. I know I'm not allowed to, but I can. Numerically, I can. It's just not kosher. People don't like it. So I divide by 3 root 17. Now, this cancels. And on the left, I'm left with the square root of x equals. Oh, well, look at that, Rachel. Isn't that nice? With 18 divided by 3. So, Rachel, the square root of which of these numbers would be 6? Square root of which one of these numbers, 3, 6, 15, or 36, would equal 36. Isn't that nice? Now, I said I would teach you a way to do this without a calculator. Now, Mr. Kinfu, do you have a calculator? Yeah. Kinfu,
Yeah,
you got a calculator?
yeah.
All right. Here's how you use it. All I would want you to do is this. I would want you to type in 18 root 17 in your calculator. Like beep, boop, 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 enter. You get a decimal, right? Could be like, I think it's like 73 point something. I don't know. I just made that up. It's probably close to 73 though. Now I'm curious. Aren't you curious? Kind of curious, right? Don't you have a calculator you can use on this phone? My phone won't turn. Piece of crap. Time to get a new phone. Oh, there we go. 18 root 17. Oh, 74.2. So what I would do, Mr. Kimfield, is I would write, this is approximately equal to 74.2. And then what I would do is I would take each one of these numbers and I would plug it in for x, and I would do 3 times root 17 times 3. Does that equal 74? No. And I would keep doing it until I got it right. It's more along the lines of guess and check. Number 3. Big fan of number 3. Love number 3. Also speaks to my love of algebra. Miss Bragg,
Hello.
how are you today?
Doing great. How are you?
Not bad. Just I'm going to do better in 30 minutes.
Okay.
Miss Bragg, is it okay that I color coded these for you?
Mm-hmm.
The first one's blue, second one's green, third one's red, fourth one's
Yeah.
black. Okay. So here, what I'm going to do is I'm going to use algebra to solve these. Okay? So the first one says 3x cubed is greater than or equal to 9x squared. And here's what I can do. Ready, Marcus? Not doing this for my health. I lied. I am doing it for my health. But I'm doing this for you. So you ready? I can divide out, meaning I can divide each side by x squared, right? That cancels with that. X cubed over x squared is x, right? So if 3x is greater than or equal to 9, divide by 3. X is greater than or equal to 3. Now, why am I doing this? It says, which of the following inequalities is true for all values of x? Well, the blue one is only true for values of x that are greater than or equal to 3. So I know that's not my answer. How do I know that early on? Well, if there's an x left, like in that step, I know that it's not going to be true for all values because there's going to be an imbalance. Remember, a true statement is when you have something that is always true, like 10 equals 10, or 9 is greater than 3. So that tells me that the blue equation didn't work out. Well, watch this. Let's look at the green equation. I distribute that where I like kind of do 6x times 6x. That gives me on the left 6x squared. Well, watch this. 6 squared is 36. X squared is x squared. Remember when I was talking about that imbalance? Do you see I have x squared on both sides? Guess what happens when I divide by x squared? They cancel. Is that true or false, Marcus?
It's true.
Notice there is no x's left. There's no more x's in play, which means my answer is that one. Now, if you went through because unfortunately your Schoology didn't like you and put this one at the end, well, you would see here in the red equation, it's x squared and x cubed. There's an imbalance of x's. So that one's not going to work. And this one, when you FOIL that middle, you get an imbalance of x's. Mark Buxer.
Yes, Mr. Harmon.
Ah, such enthusiasm.
Yep.
What's a least common multiple?
Least common multiple is,
I swear to you, you better not say the words least common or multiple.
I was just gonna say the smallest, actually.
I like the smallest.
Least common multiple. The smallest thing you can put into a number. I'm confused, Mr. Harmon.
Okay, I like starting out with smallest. So the least common multiple is the smallest number or expression that both of my expressions go into, which kind of means or innately implies that the answer is going to be larger than the other two. Now, Mark,
Yeah.
let's focus in on that term or concept larger. Which of these x's are larger, x to the fifth or x to the sixth?
To the sixth.
That means my answer better have x to the sixth in it. That one does not, and that one does not. Meaning my answer is either the 1080 x to the sixth, y to the fourth, or 360 x to the sixth, y to the fourth. And Mark, guess what I do here?
Algebra.
I realize that both my y's are the same. Why are they the same? Because y to the fourth and y to the third. Y to the fourth is bigger. It's going to be part of my answer. That's why it's the same in both of them. Now, if 24 and 45 goes into 360, that's my answer. If it doesn't, then the 1080 is my answer. Great snowboarding game on N64, by the way. Now, what you do is you do 360 divided by 24. All right. 360 divided by 24, you get 15. 360 divided by 45, you get 8. Is it 8? 360 divided by 4, 45. Is that 8? Divided by 45. Yeah. Yes! Still got it. So my answer is the 360 x to the 6, y to the 4th. Marcus, you're following along, right?
Yeah, I'm on here. I'm trying to get my answers up
Ooh, good luck. All right, next question. Owen,
Yeah.
I heard they were handing out free hugs down in guidance after a Giants loss.
Yeah.
I'm sorry. But it did make the division that much more exciting.
Mm-hmm.
And you know what makes this class exciting? This question. Owen, what do we do with the x to the 5th and x to the 3rd?
Uh,
How do I simplify that?
I wouldn't know.
Okay. Owen, let me ask you this. If you have 5 x's and 3 x's, how many x's do you have?
8 X's.
Thank you. Now, Owen, what's 8x times 8x? Meaning x to the 8th. You know what I'm getting at here?
64.
Ooh. You multiplied the exponents. So maybe that was my bad. So when we have x to the 5th times x to the 8th, we add the exponents. But when I have an exponent raised to an exponent, I multiply. So Owen, that was probably my bad. So we have x to the 16th here. Now, what do I do when I'm dividing exponents, Owen?
I don't know.
Well, if multiplication we add, then division we,
Subtract.
okay, just like a phoenix, the Giants are going to raise from the ashes.
Mm.
And maybe once again be divisional leaders. Like that. It's a good Fallout Boy song. All right, next one. All right, now, I actually like this problem. It brings tears to my eyes. Jagger.
Wait, that
Yeah.
Jagger.
said 36.
Yeah.
Question for you. The
Yep.
question is this, Jagger. Okay, it's not math related. Okay. Although I do want to know how to multiply these two binomials. But the question I have for you is this. Aluminum blank. What's the second word there? Aluminum blank. Starts with an F.
Foil.
Foil. We're going to foil this. Now, here's what I was talking about at the beginning. How much math do I need to do to answer this question? And that is this. When I multiply the first times the first, I get 3mx squared. Because m is going to act like a number. That's what it wants to know. What is the value of m? Meaning, what's that number? Then I do this times this. That gives me negative 5mx. Then I'm going to do the 2 times the 3. And that gives me 6x. And then I do 2 times the negative 5. And that gives me negative 10. And here's the thing. I just foiled it, but I didn't need to do all of that math. So Jagger, do you see how I want to know when that polynomial I just foiled equals that I underlined? Do you see that, Jagger?
Yeah.
That's what it's asking. Now I want you to pay attention to this one little part here. This little part is this. So why did I write it like this? Well, obviously the negative 10s are to match up. And these need to combine to give me that. But here's the key. Those two have to match up because they're the only ones with x squared. So Jagger, I want to know, when does 3mx squared equal 12x squared? Well, the funny thing is these x squareds really don't matter. And I'm just asking, 3 times what is 12, Jagger?
4.
4. And I don't have to address the middle piece because it comes out in the wash. That's what they said. Like any money you leave in your pockets comes out in the wash. You'll never see it again. Mom takes it. Whoever does the wash takes it. Dad takes it. Brother, sister takes it. You know why? It's the cost of leaving money in your pockets. All right. Now, when I'm doing this problem, it's done the same way. All right, it's done the same way. But here's the thing. I don't need to do the whole thing. All right, well watch. When I start to FOIL it, I have mx squared times 6x cubed. That gives me 6mx to the 5th. And notice there's no other x to the 5th that I could get. How do I know that? Because when I multiply x squared times x to the 3rd, that's x to the 5th. No other exponents can give me a 5. So I also have this piece right there. So I'm asking you really to solve this equation. Kelsey,
Yes.
Kelsey, if I asked you to solve 6m minus 6 equals 18, could you?
Yeah.
Okay, what do we got?
You add 6 to 18. So that'd be 24. And then you divide. And then you get m equals 4.
Perfect.
Is it -9?
I don't think so. All right, next one. Mr. Kitchen,
What's up?
how are you?
Pretty good.
It's good. All right, Mr. Kitchen. Now, for a problem like this, okay,
Mhm.
there's a lot of different ways we could do it. We could solve it by algebra, which is, my favorite way, and I'll show you how to do that.
Okay.
There's another great way to do this. Do you know what it's called?
Not sure.
It's called plug and chug, meaning you're going to plug your answers into the problem and you're going to simplify it. So do you see what I mean? Like I would take x equals 2, like the bottom one on my screen, and I'd plug that in for x. And I would do like 3 times 2 is 6 plus 6. You know what I'm saying?
hmm
Now plug and chug, it could either work out nicely for you or you could be sitting there for a while. So
Okay.
let me show you how to do it using algebra. Now, I do like plug and chug. I would probably recommend plug and chug on this, but here's how you do it. So first up is I would distribute that 2, and I would distribute that 6. So I'd get 6x plus 12 minus 96 equals 12x minus 24 minus 56. Start combining like terms. 6x minus 84 equals 12x minus 80 with my x's. We get negative 84 equals 6x minus 80. Then I would add 80 to both sides. Then I'd get negative 4 equals 6x. Divide by 6. You get x equals negative 2/3. Now, plug and chug for this one, I probably wouldn't have started with negative 2/3, but if it's the first one, you're working sequentially, you can lock out. You okay with that, Mr. Kitchen?
Yeah, I got you.
All right, you the man. All right. Mr. Emmy.
Hi.
Hi.
Yeah.
How would you do this problem? This is more so the stuff we just did, right?
Yeah, I would probably honestly I'd probably do it the what is it? I would do the graphing method.
Good. So how would you do that?
I would
Would you do it through intercepts? Would you put in y equals mx plus b?
probably y equals mx plus b.
Okay, well, allow me to do that for you. So first thing I would do is I would get y by itself, and I would get 2y equals negative 3x plus 6. Then that would give me y equals negative 3 over 2x plus 3. I like that. This one, I would get negative 3y equals negative 4x plus 12. And that would give me y equals 4/3 x plus 4. Nope, lie, minus 4. Forgot, divided by a negative. We'll get you every time. Now, Mr. Emmy, do you know why I like this?
No.
Well, I like this because one line, the red line, is going down. The blue line is going up. This one should be going through the y-intercept of 3. This one should be going through the y-intercept of negative 4. So when I'm looking at this, I can tell you the answer is not A, because that's 3. a line should be going through that point right there, and it's not. This guy, well, that one's 1, 2, 3. Okay, that one's going down. That looks good. This is at -4. This one's going up. I'm kind of feeling like it's that one, but let me look at this. Well, it's definitely not this one because it has 2 positive y-intercepts, and it's definitely not this one because this one, notice it's -4. That line is going down. So yeah, it was definitely B. All right. Last one. Mark. I like picking on Mark. 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 You laughed.
Yes, Mr. Harmon.
Oh, fantastic. Mark, when looking at this problem, are you overwhelmed?
Yeah, that's for sure.
No. Now, the key to this whole problem is reading.
All right.
When you read the problem, notice it says not true. Not true. So it's asking which one of these points is not in your shaded area. So the first one says the restaurant can purchase 400 pounds of lobster. So this is L, this is lobster, and this is crab. So 400 lobster, 500 crab, that's totally in there. So that's not my answer. 200 pounds of crab, that's right there. And 200 pounds of lobster, that's in my shaded area. 50 pounds of crab,
That's the one.
300 pounds of lobster, it's that one. It's not in the shaded area. So it's not a solution. So it's the 50 and 300. All right. So there you go on that. Now it's time to get out your notes. And it's about to get real. So I need you guys to open up to 4-3. And we'll go from there.